everybody, welcome. This year we are here at Indian River State College at the St. Lucie County Regional Science and Engineering STEM competition, and we have over 200 projects here today from students across St. Lucie County, middle school and high school students. Some of these students started working on their projects last year, as soon as last year's science fair was over with, and others maybe started just a few weeks ago. So we have a wide range of projects, and the students are just getting ready to share their information with the judges. Each student will have an opportunity to explain their project to a judge, explain their findings, their rationale, and explain what information they've learned from this. So it's a great opportunity for students to be able to share the hard work that they've been doing, along with giving them practice speaking to the public. So we're really excited, and we can't wait to see who the winners are.
My name is Autumn Thomas, and I go to Lincoln Park Academy. My project here is about Daphnia magna, which is a water flea that are used to measure water toxicity. They're used to measure water toxicity because they're see-through, but so you can measure their heart rate. But in this project, I wanted to see if caffeine affected their heart rate. So what I did was I made a coffee solution, mixing coffee and water, and then I put the Daphnia magna into that solution and measure their heart rate before and after they're added. In some cases, their heart rate increased, and in some cases it decreased. At the end, when I analyzed all my results, I came to the conclusion that it was possible that the heart rate increased for some of them because they were able to handle the coffee, and it decreased for some of them because they couldn't. When your heart rate decreased, probably leading to your heart rate slowing down, probably meaning you're dying a little bit. I also decided that Daphnia magna, the reaction to coffee is very similar to how humans react to coffee, because say you were to give a child coffee, they would at first have an increase in heart rate, but since their bodies aren't fully developed and they're not ready for coffee, their heart rate might decrease a little bit and they'd react to it in some bad ways. But for adults, when they're older, they'd be ready to have the coffee because their bodies are fully developed and able to consume these types of chemicals.
Hi, my name is Brianna. I am from Southern Oaks Middle School, and my project is on electromagnets. And what I did is I built an electromagnet and tested it on what metals it would attract, and I did that by using a hex bolt, and I just picked up different metals, and only 2 out of the 5 attracted. My conclusion was that the zinc and the nickel were the only ones that attracted out of the stainless steel and the aluminum. Those ones did not attract because they don't have the strength to attract. The electromagnet worked really good, but there was a lot of trial and error while building it, and that's how I did my project.
My name is Kirsten Birmingham, and I am representing Palm Point Educational Research School K-8. I did my project on which method uses less water to help us with the potential water wars that might come if we run out of water. I created my own method of agriculture that uses recyclables and use many of the modern day usages of agriculture, such as regular potted planting and greenhouse, over a 50-day course. I also consider the humidity, weather, temperature, and rainfall to see how it impacted, and the types of plants used were tomatoes and green beans. This is a project that doesn't have any data or any resources that tell you what to do step by step. I had to make all the procedures, materials, and everything by myself. I even took the pictures and made the graphs. It can help us in many ways to help impact the environment in a potentially good way and help us with the pollution problem with recyclables that we can use and help us produce more food. My method of agriculture used 9,936.725 milliliters less water than modern day usages of potting and greenhouse.
We have 205 projects representing 240 students from every public school in St. Lucie County, in addition to a charter school, a religious school, and a homeschool student. The projects this year are extremely rigorous, and shows the students' ability to do their research and come up with topics that really impact their lives and, most importantly, their future.
Once again, I am blown away by the quality of the projects that are here today. And this year I had the great fortune of judging some that were middle school projects as well as some that were high school projects. And a resounding theme that I'm hearing there is how the scientific community here in St. Lucie County is reaching out and helping our youngsters with their projects. We are so grateful for that, and the children are building real mentorships with those in the scientific community that are helping them out. So the quality that we're seeing this year is really astounding, and in fact one of the areas that I had to judge, I just kind of had to shake my head a lot because they were so beyond me in the verbiage and all of those things, but it gives me such great hope for the future, especially, for the sustainability of our universe. And these kids have such passion for the community and the world and the water qualities and all of those things that impact all of us from all ages. I asked one young man at the high school level where he got the prototype from, and he said, well, it just came to me one day. And he fabricated it totally from a vision that he had in his mind and was able to put it into a real structural, producible, and functional machine. So it's a good day in St. Lucie Public Schools watching all of these kids and how they're able to put their thoughts into action and also articulate how it will benefit the greater good and the greater community. Good day.
My name is Sebastian Germano. I go to Northport K8. I'm in 8th grade. I did which deodorant lasts longer on a black shirt. I did 3 swipes. I did 3 different tests, and I had a blow dryer for 30 seconds to see which one was most invisible. I play 2 different sports, baseball and basketball, so I sweat a lot, so I wanted to see which one lasts longer. I had fun doing this project. That degree, ultra clear, white and black, was the best one.
My name is Catherine Bigner, and I go to Mosaic Digital Academy. So my project is trying to solve the inconsistent amount of milk produced by cows and an overall better lifestyle for cows. So brushes have been invented before because of the benefit effects that they bring. They help keep organisms and bugs off the cow's hide, and brushing definitely with dairy cows triggers that happy sensation, we call it, which helps produce more of a healthy and consistent amount of milk for the cows. So we have my initial sketch here, which is basically trying to get my base of what I'm trying to do. But with more research and trying to find the materials that I'm going to use, I have a better sketch right here. So I go into testing right here. Testing is very important because I need to see if my materials are going to correspond with each other and make sure that they're working properly. Now what I did do is I did get the wrong photoelectric sensor, which is like a little beam. So when I put my hand in front of it, it should have a little green light, which is connected to a switch, which is almost like a manual switch in your bathroom, but except this one is automatic, and that's going to connect to our brush to help start it running. Because it didn't do that, I revised my research and I got one that did work and did correspond with my brush. Basically, the positive effects that come with this brush, I needed to make sure that the cows would use the brush were comfortable. So I set up a 4-day testing period. We have 2 days. of closing one of the gates and having the cows come in, encouraging them to use the brush because they are very much creatures of habit and normality. So we had 3 cows come in, and these are sets of 1. So every time a cow comes in and out, that is 1 set. So we had 3 cows come in to get a little bit of treats. Then the second day, we had 4 cows come in, and 1 cow was so excited, they came in and out, and that shows just how much they like the brush. Now, the 3rd and 4th day, we opened up the gate, so now this is the choice. We're gonna see how comfortable this is. And remember that this is only the 4th day that this thing has been in their pen. 2 cows have come into the brush, in and out, in and out. Now, we're gonna see something very interesting on the 4th day. We have 3 cows, so even when you think that they could leave and they could use the other one that's more normal, because they like the brush, another one went in and another one decided to go in and out again because they like this brush so much. So basically this is going to be more accessible to farmers. It's better for the environment. We used a lot of recycled materials to build this brush. We're trying to get it more flexible so that more farmers can use this. In conclusion, this brush is going to be more accessible to more farmers. It's going to be more environmentally friendly, and it's going to help more cows.
My name is Nathan Klein from Westgate K8. My project is about if the durability of plastic can save our environment. Because the plastic is more durable than regular paper, it can save our trees, help save the animals from deforestation. It can decrease pollutants in the air from plastic manufacturing. It can help decrease the greenhouse gas effect because of the more trees it goes less carbon dioxide. And then one of the most important things is if you use this, it can help make government documents. Because if you use this to make the government documents such as social security cards and birth certificates and marriage certificates, it's much more durable. That means the marriage certificates and all the government documents have a less likely chance of tearing and ripping. And the way I did this is it's actually very easy. All you have to do, this is an example of the paper. All you really have to do is just take 4 plastic bags, cut them into sheets, iron them together, and put them in the oven for about 30 minutes. And the average of the plastic held more than the 2 papers combined because we used printed paper, the plastic, and the lined paper. We used weights. We put weights on every single thing on them for about 5 seconds. Every 5 seconds. I can make this better by using more objects besides just weights. And then I can also make it better by using testing more than one thing, such as the printability and the water resistance of the plastic. And my hypothesis was, I believe the plastic will be better than the two papers because plastic is made to be non-biodegradable. And my hypothesis was correct because, as you can see, the plastic held a lot more than both of them.
Hi, I'm Igor Bushnin from Lincoln Park Academy.
And I'm Kaylee Larman, also from Lincoln Park Academy.
Our project is about burning fossil fuels and comparing it to non-renewable and renewable resources.
So in our project, we decided to ask ourselves the question, which fuel gives off the most energy when burning? Now, our purpose for this project is to compare non-renewable resources to renewable resources. In our environment, we use fossil fuels every day. I mean, cars, planes, buses, we're putting pollutants into the air constantly. And eventually, they're gonna run out. For our generation, in the future, there's not gonna be any non-renewable resources left. So, in our project, we're trying to get a kickstart to find an alternative.
So, our hypothesis was that diesel, compared to motor oil, vegetable oil, methanol, and ethanol, would have the most heat energy because it's the gas we use the most, and it contains these things called hydrocarbons, which are very stable compounds that when they burn, they give off a lot of heat. And these compounds are like carbon-carbon and carbon-hydrogen. So our procedure.
So for our procedure, we took a ring stand and a soda can. We cut the soda can in half and filled it with 100 milliliters of water. We recorded the temperature of that water. And then we took a cotton ball and put 35 drops of each fuel for each test onto the cotton ball. And we took a grill lighter and burned it, recorded how long it took for it to burn out completely, and then recorded the end temperature. Our conclusion?
Our conclusion was that diesel did in fact give out the most heat energy, and it had the second to longest duration of burning, right behind vegetable oil. Vegetable oil didn't give off as much heat energy, but it did burn for a long time. And one of the biggest things that we noticed about this project is that ethanol and methanol, which are big non-renewable fuels, they had bursts of energy in the beginning, but then they diminished their flame very quickly. So it would take twice as much methanol and ethanol to achieve the same results as diesel, which in today's perspective is a very big thing for the government in terms of pricing for gas. So we would have to pay twice as much for ethanol and methanol gas than for regular diesel.
And if we could change anything about this project, we would change what we use to record everything. So we use a calorie meter right here. I'm sorry. We use a multimeter, but if we could change anything, we would try and use a calorie meter.
Yeah. Also, the conditions, since we did it outside, the temperature outside and the sunlight could have affected our results. So doing this in a lab would definitely improve our project, and maybe also considering the amount of pollution each gas gives out, which is a big problem today.
So the classroom students have to make a project, okay? We judge them in class, then we take the best ones, put it into a school fair, and then those cream of the crop go here. So the top X number from the school fair go to this fair. Creativity, uniqueness, good science, good data, lots of data, stats, things like that.
My name is Brooke Formica. I'm from Treasure Coast High School, and this year I decided to do my project on garbage on private versus public beaches. Now I'm very passionate about the environment. As you know, that there's a lot of pollution nowadays. I'm also doing a project on the effects of carbon emissions in the atmosphere. But another sort of pollution is the plastic that is seen on the beaches. There are many studies indicating that there are plastics that the animals in the ocean ingest, and it's terrible. So I wanted to see if there were rules and regulations on a beach, would it make a difference in the amount of trash that is present? So I went and decided that I was going to visit a public and a private beach 3 times each and collect trash for an hour. So the first time I visited, I noticed 2 significant differences between the public and the private beach. For the public beach, it was free access. Anybody could come into the beach. It was very busy. It was way busier than the private beach. As you could see there, this was a picture of the private beach. There was little to no people there. When I went to the private beach, it was in fact, I was immediately greeted with a guard at the gate, and I had to pay $6 in an entry to actually go there. There was a lot of rules there. There was prohibiting alcohol. No pets were allowed. There were speed limits that I had to drive, and certain parking spaces that I couldn't use. So as you could see, there were many different there were many different rules that was a significant difference between the public beach. So the first time I went to the public beach, it was November 22nd, and I collected 122 pieces of trash there. So there was a significant difference. You could see that there was lots of food packaging, small little plastic cups, aluminum cans, just a lot of little things, but it ended up being 122 pieces. When I went to the private beach for the first time, there was a significant difference. I only collected 61 pieces of trash, and that was on December 2nd. And you could see that there was a way smaller amount. Even though there was weird items, like this was underwear for some reason, there was still a very small difference. The second time I went to the public beach, it was December 6th, and I collected 88 pieces of trash. There were huge plastics, there were 2 aluminum cans, huge, I think this is a spoon, there was just napkins, everything. So this was the second time I visited. The second time I visited the private beach, it was December 8th, and I collected 40 pieces of trash. Even though I collected a little bit less than half of what this was, there was a lot less plastic. I mean, there were small little straws, plastic cups. There's like 2 cups here. Meanwhile, this was just insane. The final time I visited the public beach, it was December 18th, and I'm guessing it was a day after a party because this picture simply does not do justice about how much trash there was on this property. This in total, just this, was 5 pounds alone, with aluminum cans, beer bottles. It was ridiculous, and in fact, it was actually right next to the trash can. They were just too lazy to throw it away, unfortunately. That was 93 pieces of trash. Items were, huge cans and stuff. And the final time I visited the private beach, it was December 20th, and I only collected 28 pieces that day. So as you could see from my results, my hypothesis was definitely supported. I did believe that there would be more trash on public beaches versus private beaches simply because of the rules and regulations. I did end up weighing two of the differences. In total, the grams that were collected from the public beach, there were 2,449 grams of trash. Meanwhile, the private beach only had 102.3 grams in trash. So there was a significant amount of difference. And the total amount of pieces that I collected, the public beach had 303 pieces, and the private beach had 129 pieces. So in the future, I hope that I can make a difference by talking to city officials and either enforcing more trash cans on the actual shore because there was only trash cans in the front of the beach. I think that's what the problem is, or prohibiting things such as alcohol, because as you could see, there was few incidences where alcohol was found on the beach that wasn't thrown away. Meanwhile, the private beach prohibits alcohol. So I think that there needs to be more rules and regulations to fix this issue. And that's my project.
Hi, my name is Katya Oje. I'm from Treasure Coast High School, and I am a junior. Now, my project is about filtering water. I'm trying to test if we could find a way that we could filter our water so fertilizers and pesticides don't go into our aquifers. Now, I used a 2-liter bottle and I filled it up with sand, dirt, and rock to try to filter out the water. But the trick that I used is putting a coffee filter right before the artificial grass. And my project didn't come out the way I wanted it to come out. My hypothesis was wrong. But with that, I did learn how to fix my hypothesis, continuing my project later on. And I found that the coffee filter did somewhat help, but it didn't do an extreme amount it didn't increase the water quality that I thought it would. And now that I know that I could check the fertilizers and pesticides, instead of using actual fertilizers and actual pesticides, I could use salt and food coloring to test it out. And there's other ways that you can test out your project. My conclusion, let's see. My hypothesis was correct, but it was not as correct as I thought it would be. My hypothesis was, I believe that if I create a coffee filter like barrier before artificial grass, the quality of water will drastically increase. And it did not drastically increase. We could check with the salinity. Before, the salinity was 1,024 parts per thousand, and with the coffee filter, it was 995 parts per thousand. So it did help, but it didn't help drastically. So that's what I want to say. Science fair doesn't always go out the way you want it, but you do learn something from it. Thank you.